The session is recorded. Now, today we are going to talk about the important transformations of Spark. First thing will be reduce by key. Before you understand reduce by key, I wanted to revise that we have already discussed that data will be distributed along the data nodes, which will have partitions. Okay, so now, for example, if you see this diagram here, reduce the dataset's value based on the key. You know what is a key, you know what is a value. Reduce by key simply reduces the dataset values depending upon the key. If this is the key and this is the value based upon the, yeah, please.
I can't see any diagram on the screen. I'm sorry.
Can you see Ramprasad?
Yeah, I can see it. The paper in which it's been written. Yeah.
Yeah. Okay, now this is what the reduce by key is. Now you need to understand one thing here. Reduce by key works only on one dataset, which is RDD. RDD is resilient distribution dataset. Okay, each RDD can be partitioned across the data nodes. That's what I told you. Okay, this one, this partition 1 will be on node 1. This partition 2 will be on node 2. This partition 3 will be on node 3, and you are accessing it from a gateway node. Okay, for example, these three partitions can make one file because your file will be broken into block and one block is based on one partition. Okay, that's what it is. Now try to understand. Okay, reduce by key works on each partition. Okay, locally means when reduce by key is applied on this block, the transformation will be applied locally on this block. When reduce by key is applied on this block, it will be applied locally on this block. When reduce by key is working on this block, it will be applied locally on this block. The reason why it is applying locally is just to have utmost performance without any issues. Okay, once the transformation applying is completed, this one with this one with this one will be commonly collected at one point. That we'll discuss in next 2 minutes. Okay, now let's see here. I'm clearing the drawings. I draw again. Okay, for example, k1 is the key and associate value is a tuple. Okay, for example, k comma v means key comma value, which is k comma 1, k comma 2, k comma 3, that is key value pairs. This will be key, this will be value, this will be key, this will be value, this will be key, this will be value. But when you have a key and one can you see my writings? I'm writing something. Can you see that? Guys, with a black pen, I'm writing something. Can you see that?
Yes, Amar. Yeah.
Perfect. Now, if I have a key and a list of values, that is called a tuple. You need to understand the difference between key value pairs and tuples. Now here we are discussing through tuples. Okay, try to understand. This is one key and tuple from partition 1 or partition 3. This is one key and tuples from partition 1. This is one key and tuple from partition 3. Okay, now this one is this one, this one is this one, this one is this one. That's how your data will be segregated, how your data will be broken into blocks, and how each block will be treated as a partition. Okay, that's what it is. Now If you see 1 comma 2, this entire value is tuple. It is not just one, it's just not one key and one value. One key and entire value. This entire value is called a tuple. Okay. Now, same partition can contain multiple keys. You're right. That's absolutely right. Multiple keys means this key with multiple partition, multiple values, this key with multiple values, this key with multiple values, this key with multiple values. That's what it is. Okay. Now, the dataset partition across the nodes in the Hadoop cluster are represented in a single RDD. Single RDD means, now let me show you once again. Okay. Now let's focus on partition 1. Okay. Now single RDD means K1 1 comma 2, K1 1 comma 7, okay, K2 1 comma 8, K2 2 comma 9, K7 1 comma 8, K1 2 comma 6. This is all one partition. Okay. Once again, I repeat, you need to understand this carefully. Don't get confused. The data set partition across the nodes in the cluster are represented by a single RDD. Okay. So first of all, this one will be a part of RDD. This one will be part of RDD. This one will be part of RDD. Once you finish applying reduce by key on this partition, on this RDD, you move to this next one. Once you complete finishing on this one, come to third one. Okay, that's how it logically works in the background. You need to understand it. Now, this is what the syntax of your reduce by key is. Okay, syntax will be reduced by key uses two what we call what is that called? 1 minute. It's not variables. Two arguments. Okay, this is one argument and this is two arguments. Okay, now for example, this is your key, this is your tuple, this is your key, this is your tuple. Now consider this one as x, this one as y. Are you all with me? Are you all with me, guys? Are you all with me?
Yes, 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 Amar. Yeah.
Okay, perfect. Now if you see here, for example, if you say 1 comma 2 comma 3 comma 4 comma 5 as your elements in an RDD, you start with 0. Okay, 0 plus 1 is 1, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. Okay, 10 plus 5 is 15. Correct? Are you with me? That is the
Yes.
standard way. Now, you said 1 comma 2 is x. Okay, 1 comma 7 is y. Correct? That's how you considered. Now, you need to apply this thing to both of this. Okay, that is the iterative algorithm implemented one by one. Okay, so that's how I say reduce by key needs two inputs, two arguments. Okay, let's see what are those arguments. Are you clear till this point? We have discussed very important bit, that is nothing but RDD is nothing but a data elements made out of the partitions from the nodes. Okay, now you know what is a key value pair and you know what is a key and a tuple. Tuple is nothing but combination of values which can be 1 comma 2, 2 comma 3, 4 comma 5, like that. It can be of anything. That's how it works. Okay, after that partition reduced by key uses two arguments. One is reduced by key x comma y. X will be your first element, y will be your second element, and how you implement the iterative algorithm of that is important. Okay, let me move on to next page. Clear till this point, everyone? Any questions?
No, Amar.
Okay, now
No, Amar.
perfect. Now let me show you this one. See here, we know reduce by key is just two arguments, right? This one, reduce by key uses two arguments, which is x comma y. Now, different value from same key. Okay, you have k1 1 comma 2. Okay, you also have k1 1 comma 7. Okay, now try to understand. Let's go one step back and have a look. Let's go one step back and have a look. Do you see here? Now you are applying the reduce by key only on this one. Please remember, you are applying it only on this one, not on this one. Having said, we will do one by one. Okay, this is on partition 1, this is partition 2, this is partition 3. First complete the work on one partition and go back to second partition. Complete that one and move to third partition. That's how it works. Okay, erase all drawings, go to the pen, first go to pointer. Okay, now have a look. So you have 1 comma 2 as value and 1 comma 7 as value for the same key, which is k1 k1. Now when this is x and this is y, okay, the complete syntax will be x plus y. Okay, x plus 5 means 1 plus 1 is 2, 2 plus 7 is 9. Okay, what is the new RDD? What do you know about immutable means? Immutable means whatever the change that happened to your RDD, that will go and form a new RDD. Correct? So one k1 is same key, k1 is also same key, means your reduced by key is operated on the reduced by key is reducing the values based on the key. Now when this is x and this is y, x plus 5 means 1 plus 1 and 2 plus 7 9. So like this you have k1 is 2 comma 9. So when you worked on two tuples, you formed a one tuple. Okay, that is a standard example. Now the syntax for this one is data rdd dot reduce by key x comma y x dot underscore 1 plus y dot underscore 1 comma x dot underscore minus underscore 2 plus y dot underscore 2. Now don't confuse yourself. I'll explain that what I mean to say. Go to pointer, erase all drawings. Okay, now guys, focus, be careful. One comma 2 and 2 comma 7. Okay, you are with me, right? You're all with me, right? Now x of underscore 1 means this one, y of underscore 1 means this one, x of underscore 2 means this one, y of underscore 2 means this one. Having said, your tuples always starts with, for example, 1 comma 2, 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 like that. Okay, considering this one, when I say x dot underscore 1 plus y dot underscore 1 means 1 plus 1. Okay, when I said y dot underscore 1 plus y dot underscore 2, it is 2 plus 7, which is 9. This is the newly formed RDD. Now take the first value of x and also take the first value of y. Okay, and apply the summation. So first value of x is 1, and first value of y is 1. Take the first value of y and do the summation with second value of y. That's what we did. Now similarly, take the second value of x and the second value of y and do the summation. That's what we did. Okay, now as it is an iterative algorithm, it scans through all keys in the data set across the partitions. Now let me go back to now you didn't understand something here. As this is an iterative algorithm, iterative means keeps running, keeps running, keeps running. Okay, that is iterative algorithm means. As it is an iterative algorithm, it scans through all of the keys in the data set. Okay, now you understood everything till this point. Now let me show you something, guys. Please be careful. Okay, go to pointer. Now pen. So k1, k1, k1. The result of this two is 2, 9. Correct? Are you with me, everyone? Now this is sorted. You have other key one, right? Which is 2, 6. So what will happen now? You'll have to count. 2 plus 2 is 4 and 9 plus 6 is 15. 4, 15. Very good. Now go to next key. You have same keys. K2, K2. 1, 8, 2, 9. So 1 plus 2 is 3. 8 plus 9 is 8 plus 8, 16 plus 1, 17. 3, 17. Okay. This K7 1, 8, you can't do anything because this is only one time repeated. Is it K1 or K7? Is it 1 or 7?
It looked like 7.
Yeah, okay. We'll sort it out later. Okay. Now, what is the result of this partition? The result of this partition is 4, 15. Okay. 3, 17. Okay. And 1 minute. 3, 17 and 1, 8. This is for this partition. Now work on this partition. In this partition, this is repeated key, this is repeated key. So 1 plus 1 is 2. 4 plus 9 is how much? 13. Okay. 2, 13 here. Okay. And K4 is repeated, K4 is repeated. So 1 plus 2 is 3. And 4 plus 7 is, 4 plus 7 is
11.
Okay, done. This is not repeated, so leave this as is. Okay, now let's come here. K6, K6. 1 plus 1 is 2. 4 plus 8 is 12. Very good. And K9 is repeated. 1 plus 1 is 2. 7 plus 1 is 14. Now let's go back and see if you are getting the same results. Erase all drawings. Go to pointer. Okay, now go to pen. See. So partition 1, this one. Partition 2, this one. Partition 3, this one. Okay. So earlier you had so many things, that so many things are broken into individual partitions. Now you have reduced based on the key. This key is not repeated. 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 This is not repeated. This is not repeated. So based on the key, your values are reduced. Earlier you have so many values. Now you have made a summation and reduced those values based upon the key. That is called reduce by key. Clear, everyone? Are you happy with the explanation? Any questions? Let me know. I'll move on to next thing.
No, I'm not fine.
Perfect. No
Clear?
question.
Very good.
Yeah.
Very good. Now let me go to the second bit. Second bit will be this one. Okay. Let's understand carefully. Now, group by key. We are talking about group by key. Group by key is nothing but you have an array. Okay, this is your RDD. In this RDD, you have a string 1, string 2, string 2, Hadoop, Hadoop, Hadoop. Okay, you generate an RDD using sc.parallelize words. Okay, you know sc.parallelize means. Sc.parallelize means you create an RDD. While creating an RDD, you apply a map function. Okay, while creating an RDD, you apply a map function. When you apply a map function, one minute guys. Okay, something was in my eyes, so I thought I should clean it. Now, you all know what is a map function, and you know what is a word comma 1. So what happens is this one will be 1 comma 1. This one will be 2 comma 1. This one will be again 2 comma 1. Like that, every word will have a value 1 as a value with the word as a key. That is key value pair. Now let me explain you this one. Val word is my array element. Parallelize distributes the data across the cluster. Are you with me? Are you with me? Now, map function picks up each element in the list and generates the results based upon the function defined. Yes. What is the function defined? I'm telling for each word add 1. So 1 comma 1, string 2 comma 1, string 2 comma 1, Hadoop comma 1, Hadoop comma 1, Hadoop comma 1. Okay, that's how it forms. For each element, it will generate a tuple. Now, this is a tuple, this is a tuple, this is a tuple, this is a tuple, this is a tuple. You need to understand the difference between key value pairs and tuples. Okay. Now, group by key. Wherever the same key is available, group it. Simple. Group by key. Reduce by key means based on the key, reduce the values. How are reducing the values? If it is the same key, your values are being summed up. So when K1 has keys like 1, 2, 3, 4, 5, you are just doing 1 plus 2 plus 3, 4, 5. That's why you are reducing the keys. Awesome. Like that, group by key means if you have a same key, simply group them up. How are grouping them up? See, I got Hadoop 3 times. I got 2 times. I got 1 time. So 1 comma 1 comma 1, 1, 2. Okay, clear till this point, everyone? Any questions?
No, Amar.
Any questions, Lavanya?
No, Amar. So far good.
Okay, cool. That's perfect. One second, guys. Give me a minute. Somebody is asking me a question here. Okay, so this is how your group by key, if it has the same key, it groups up everything. Okay, the syntax. Now I forgot to tell you, can you please write down the syntax here? Reduce by key syntax. If you remember this one, you are a very good Spark developer.
Amar, I have a question here.
What?
For group Y, if the key is like 2, 1 and 2, 2, then there will be two different groups. As in, can you have the same key name with a different value?
Sorry, come again. What is it?
Like there you have grouped 1, 1,
Mm-hmm.
then you have grouped 2, 1, right?
Mm-hmm.
So if I have 2, 1 and 2, 2,
Mm-hmm.
then there will be two different groups.
How will you have two, by the way? Tell me.
No, that's what I'm asking. Can you have the same key name with the different
See,
value?
here in my program, I said for each word assign number 1. When I say assign number 1, where will you get 2?
Oh, okay. Got it.
Word comma 1 means for every string, go and assign a value 1. That is reason 1 came up. That is one point. Point number 2 is based on the key, what are the values? For same key, if I have some values, I can group them all together. That is the concept which we need to discuss practically. Before going there, I forgot to tell you, please make a note of this one, the syntax of reduce by key. Tomorrow morning, when we join the class, I want you to answer this question without any reference. When I say, Shilpa, give me reduce by key syntax, you must say data rdt dot reduce by key x dot underscore 1 plus y dot underscore 1, comma, x dot underscore 2 plus y dot underscore 2. If you understand this,
It's 6 o'clock.
if this is feeder in your mind, you will never forget these transformations. So make a note of it. I'll explain the group by key now. I hope your answer is clear. Your question is clear.
Yes, yes. Good. So you're saying you initialize that way?
You're right. Yeah. Let me know once you're completed. I'll start off.
Yeah, I'm done.
Perfect. Now, group by key. This is the syntax for group by key. Can you please make a note of this one? No, wait. Let me first explain it and then we'll do it. Okay. Now, erase all drawings and take a pen now. Now, see this operation here, generate pair RDD dot reduce by key, and then you implement underscore plus underscore plus underscore. Okay. The thing how it does is performs a plus operation on all the values in the group, not across the group. Okay. Now, for example, when you said Hadoop 1 plus 1, Hadoop 111, this is 1, this is 2, this is 3, right? So, when I say plus operation on the same group, okay, it says 1 plus 1 plus 1. So, you have 3. Like that, you have this one here, this one here. So this is 2 comma 2. You have only 1 now, so it is 1 comma 1. That's how you apply a plus symbol on all the groups. All the groups mean all the similar groups. Once again, performs a plus operation on the values in the group, not across the group in the same group. Okay, performs plus operation on all the values in the group. Okay, this is done. Hadoop is one group, 1 is one group, 2 is one group. So on each group, it has done a summation of the values and reduced it. Okay. Now you may think, what the hell is the relation and link between group by key and reduce by key? If you see here, you are applying reduce by key and group by key. Okay. Remember this as a bandagurtu. In group by key, you are applying reduce by key. Okay. Without reduce by key, none of the transformations will work. Reduce by key is a minimum requirement for every transformation. That is the starting point of applying the transformation. Okay, clear till this point? Erase all drawings, go to pointer, go to next page. Okay, now second approach for group by key. Let me take a pen. Now see guys, group by key just groups the data. On top of it, it applies the functions. Okay, now if you see here, generate RDD dot group by key. Okay, and you apply a map function. You have a tuple t. Okay, now your tuple t dot underscore 1 and tuple t underscore 2 dot sum. Okay, in here t means tuple. The first t represents the entire element. Okay, now don't worry about it. If you see here, this is this one, 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 this is this one. Okay, now tu means tuple. Hadoop 111 will be 3, Hadoop 111 will be 2, 2 will be 1. Okay, now let me erase all drawings. Guys, let me tell you, this is the second approach. The first approach was shown already in the previous slide. Okay, this is second approach. Okay, now if you see here, t dot underscore 1 is Hadoop, this one. T dot underscore 2 is 1111. So you're asking the map function to sum it up. What happens? 1 plus 1 plus 1 is 3. So you have Hadoop comma 3, 1 comma 2, 2 comma 1. This is group by key. You are grouping up and summing up the values of the key that falls under same group. As simple as such. Okay, now avoid group by key as much as possible. Why? Reduce by key and group by key results are same. Yes, that's correct. Because let me show you. Go to pointer. What did you do here? 2 plus 2. Wait. What did you do here? You counted this one plus this one and this one plus this one, which is summing the keys, summing the values based on the key. What did you do here? You did the same work. Here you did the same work, but you grouped the keys and you reduced the values based on the groups. Okay, erase all drawings, go to pointer. That's what it is. Now reduce by key works better. Group by key first shuffles and then aggregates. This involves huge traffic, recurring performance issues. Think twice and thrice when you think of using group by key function. Refer to Databricks best practice documentation, which I will show you later. I have the documentation ready. I'll show you that later. So now you understood reduce by key, you understood group by key. Reduce by key is most better than group by key. Avoid group by key as much as possible. The problem is group by key first shuffles the data and then aggregates the data. This involves a lot of traffic recurring performance issues. Okay, so that's what it is. Do you have any questions on reduce by key and aggregate by key? Any of you?
No, man.
Clear? Lavanya and Shilpa?
Yes, Amar.
Perfect. Now let's go and start.
Amar,
Fold. Yeah, go ahead.
can you give one more example, like how it is here? Because I'm not, though I understand the concept, I'm not getting like why you were initializing only those values. Why, I mean, in aggregate, why is the value always one?
Where do the values start from?
One?
That's it. Simple. You had answer.
No, but I mean, the key can have multiple values, right? Why are we always using one and
No, 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 no. Listen, that is just an example. Okay.
Mhm.
Now, if you have listened or if you have watched the earlier Spark slide, every time when a key is read, the first occurrence will be marked as 1. The second occurrence will be marked as one more 1. Third occurrence will be marked as one more 1. So, same key 3 times. So 1, 1, 1, 1, 1 like that. Every time it occurs on each, I told you earlier, every transformation works on partition based. In one partition, you have multiple keys and their corresponding values. Okay. Before it goes to second partition, it has to complete the function on first partition. In that partition, how many times the key is repeated is categorized as 1. Okay. Now,
Mhm.
it is not the value it had. It is the value that you create based upon the time it has occurred. That is, a map function has done the work. Clear?
Oh, okay, okay.
Perfect. Now, tomorrow when I ask you, I want you to please answer the questions clearly and precisely. This is very important. This will be foundation of your development knowledge. Now, this is, let me take the pen. Can you make a note of this one? Group by key. This is a group by key. Make a note of it. Please let me know once you're done.
Amar,
Hmm.
in that you opened the brace after map. Where did you close that brace?
Mm-hmm. It will be closed at the end. Good catch. Good catch. I appreciate it. It will be closed here. This one.
Yeah, we're done.
Sure. Thanks, Lavanya and Ramprasad.
Yes,
Thanks,
I'm done.
Okay, perfect. Let's start now. Let's continue. Okay. Now, the next bit is fold by key. Fold by key means, for example, this is the syntax for fold. Okay. sc.parallelize 1 to 10 of fold 0. Okay. 1 to 10 will form elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very good. And when you say fold of 0, it will first form an accumulator and an element. Later, it will count that accumulator and an element. Now you need to understand what the hell is this accumulator and what the hell is this element. If you understand that, you will understand you are done with the fold by key as well. Okay. Now, let me explain you that one. Okay. Now, example, let's take example as 1, 2, 3, 4, 5. Okay. When I say fold this set with 1, for the fold operation to start the summation, it needs an initial value to start which is as 0. Okay. Using 0 won't impact the correct result. 1 will always be 1. Okay. For that reason, 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. You have folded it from 0 to 5. Sorry, 1 to 5. But you initialized the starting count with 0. Now, let's understand accumulator and element is important. This 1, 2, 3, 4, 5 are elements. Your 0 is the initial accumulator. Okay. So, the first pass will be 0, 1 is 1. Second pass is 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. So you have 1, 3, 6, 10 as the newly formed RDD, which was 1, 2, 3, 4, 5. You have 5 here and they are folded into 4 here. Okay. Now, this accumulator is nothing but 0 and the element is 1. Like that, 0 plus 1 is 1. Once this is completed, what is a new accumulator here is 1. What is element here? 2. So 1 plus 2, again 3. 3 is the newly formed accumulator. So 3 plus 3 is 6. 6 is the newly formed accumulator. Okay. 6 plus 4, 10. 10 is the newly formed accumulator. 10 plus 5 is a 15. So accumulator and element, that's how it iterates. That is fold by key. Do you have any questions on this one? Let me know. Guys, the only reason why I have asked for 1 hour classes, at least in 1 hour you will feel comfortable and you will focus on the whole concepts. This is very important for throughout your journey. Okay, so kindly understand each and every sensitive part carefully. Hope you understood the accumulator now. Hope you understood the elements now. If you have any questions, let me know. I'll repeat that once again. Go through it. Go through it. Understand it. Let me know if any questions.
Amar,
Yeah.
how do you know in which context, like where to use which key?
What?
I mean,
Switching key. What do you mean switching key?
which algorithm, like as in reduce by key or group by key or fold by key?
Okay. Very good. See, based upon if you are going to do a complex aggregation, having known it is not good results, you'll use reduce by key. In the certification exam, if they ask you to implement aggregate by key, you'll implement aggregate by key. But you have to know the difference between reduce by key and aggregate by key. While implementing the reduce by key and aggregating by key, the way you sum up your values in reduce by key and the way you aggregate or when you the way you group by key, where you the way you group your keys, the concept must be clear. You implement whatever you want, nobody cares. But exclusively if they want to implement aggregate by key, I would aggregate by key. Okay. Logically, if you observe carefully, aggregate by group by key does the same work, reduce by key done the same work, fold also done the same work, but the only difference is how you initialize the initial uh, argument. For example, 0 as accumulate and fold. Okay, and in group by key you grouped all the keys and then the values, whereas in reduce by key you had x comma y, x of underscore 1 plus y of underscore 1 and x underscore 2 plus y of underscore 2. That's it. Clear?
Yeah.
If you make a note, I'll finish off. Just make this note, this one, this bit fold, and also this one, the fold operation to start a summation, it needs an initial value to start with which is defined as 0. Just make that note. Done, guys?
No,
Yeah.
not yet.
Okay, so the next bit, let me move on. I think this is enough for today because this explanation needs some more time. Okay, this one I'll explain tomorrow. The second approach of fold by key, or let me explain this one and close it off. Okay, this is very simple. Let me explain that. Okay, now we are talking about second approach. The second approach will be count elements in the list. Let me take a pen. Count elements in the list. Okay, your list is this one. Okay, counting the elements will be very simple. 3, 6, 10, 15, 21, 28, 36, 45, 55. Okay, now this fold function is applied on each key individually. Okay, before that 0 will be initialized. 1 is 1 key, so the newly formed accumulator is 1. So the next thing it will apply is for 1 plus 1, 2. 2 plus 1 is 3. So this will become accumulator. This will become element. 3 plus 3 6. 6 is the accumulator. 4 is the element. 10. 10 is the newly formed accumulator. 5 is the element. 15. 15 is the newly formed accumulator. 6 is the element. 21. 21 is the accumulator. 7 is key. 28. 28 is the newly formed accumulator. 8 is the element. That's how it works. Now, fold by key requires a dummy value similar way as we have 0 as accumulator. Okay, the dummy value can be anything. When you do a summation, the value should not change. Okay, the perfect use case is find the maximum score by department. Okay, this use case I'll explain tomorrow because I have to explain you how we can shuffle a key value pairs into tuples and how key value pairs will be referred differently when compared to tuples. Today you have understood reduce by key, group by key, and fold. Reduce by key uses x comma x dot underscore 1 plus y dot underscore 1 comma x dot underscore 2 plus y dot underscore 2. That's it. Aggregate by key or group by key uses initially uses reduce by key syntax. On top of it, it does the summation based on the group. That's all it is. Fold, it folds wherein it requires an accumulator in the first place. This accumulator will be counted with element. When accumulator element is counted, a new accumulator comes into place. This new accumulator will be counted to the next element. That's how it iterates throughout the completion of the elements. Clear till this point, everyone?
Yes, Amar. Yeah.
Any questions, Shilpa and Ramprasad?
No, Amar.
Perfect. That's all I have for today. See you all tomorrow.
No
Continue,
problem.
conti-
No
continue.
questions, Amar.
Thank you, sir. Continue this till Friday. We'll finish off everything. So next, there are a couple of bits I have to explain with HBase, Kafka, Flume, and all these things. We'll finish it in 10 days. Okay. Thank you for joining.
Amar, is the class at 5 or 5:30?
No, we'll have. That's what I'm telling you. If you guys can sit for 1.5 hours, I'll be happy. But I don't know why people are losing interest or losing the commitment. I thought let me make it 1 hour session. At least that way I can make you sit.
I think this is fine, Amar.
Okay, we'll have 5:30 to 6:30. 1 hour is fine. Okay. Thank you, everyone. Have a good
Perfect.
day. See you all tomorrow.
Yeah, bye.
Thanks. Bye.